heads up. Is my screen slideshow visible?
Yes, it's visible.
Okay, cool. Thanks. So, thanks for the introduction, and welcome to everyone who's on this call. And uh, I see a few people here because I know from my first year that very few people are into Android and they pursue Android going forward as a career. But when I was in my first year, I stick through it, and what I'm doing now, my job is also as an Android developer. So the few people, those who are here, I'm sure that for the last 4 days you are attending these sessions, then you are serious about doing something in Android. So I would be more than happy to explain you guys as much detailed way as possible. And today's session is for the last 3 days. How much I have seen, it's everything on how Jetpack Compose is implemented in Android, all the coding part using states, using different functions, what are composable functions and everything. But since it's the last session, I wanted it to be something concluding, something which concludes all the things that you have learned, and on a why on why Compose came and why not XML. Because if some of you guys have started Android, or if someone here who knows Android knows that XML is something we have been doing from quite a long time. So let us today explore why Compose and why not XML, and how should I go forward in Compose or slash XML. What should I do? So just a final heads up. My voice is clearly audible, right? Hello. Anybody of you?
Sorry.
Yeah, my voice is clearly audible, right?
Yes, it's perfect now.
Yeah, cool. Okay. Going forward. Okay, so why such a geeky session? That's one question that you might get, and many of you have just crossed first year, and you guys have seen there are multiple sessions going on in college. So why do you need such sessions? So when I got started with Android, or when my friends got started with web or ML, it was the year of 2018, and we didn't have much resources to refer to. Like for example, in YouTube there were a few YouTubers who posted videos, and it was just that Geo came in and the people started posting videos, but there weren't any expert sessions where we used to get some knowledge from people, or we used to understand how other people think in the industry, how the industry is performing. But slowly moving forward, the time when I became a GDSC lead, and after that, when more and more such sessions came into limelight, we used to see in YouTube, we used to see in LinkedIn such sessions are being conducted. Then we saw that we could understand from people how the industry functions, because the code that you write in any project, and like for example, you might have made any ABC project. For example, everyone makes a note application, every other person makes it, and that is a very basic project that you make at the starting, and the code that you write, it is never industry ready. Even one of the final projects that I have made in my college career, it was for Smart India Hackathon, and that was also when I compared with the code that I write currently in industry, that is not comparable at all. The industry code is very differently written than what are the codes that you write in projects. And through these sessions, the main motive of sessions, how workshops and sessions are different. Workshops will teach you the basics of writing the code. Sessions will more give you a proper insight on how an experienced person thinks about the code and how to move forward. So such sessions will help you to write better code. And when you move forward in your career, when you join in as an SD in any company, at that moment it will help you to write proper codes. I am myself working as a full. I'm myself working as in the industry for the last 9 months, and I'm learning to write more better codes. And as I joined the industry, I had the prior experience of Android, so I thought that what will I know more here? But joining the industry, I knew so many things. Like I feel bad of the when I see the code that I've written earlier in my projects. And now the code is so more refined and so more structured. So that's why you need such geeky sessions, as I always call it. So how boring will it get ahead? I had on the previous sessions, and it was more on the practical side, and a lot has been taught on how to use different functions and everything. I have tried to kept it as short as possible, hardly 15, 16 slides, and I will try to make it more interactive so that we get more time at the end for a Q&A with all the people who have joined. And we'll more of go through understanding how Compose came in and why we need Compose. Because if you don't understand the need of Compose, you won't get the gist of doing Compose. The same thing happened with Kotlin when Kotlin was brought in earlier. So we'll keep it as short as possible. And going ahead, I will go on through the slides. If you have any issues or if you get any questions, you can the Q&A section is on. You can just put it out there, and when we reach the Q&A part, I will discuss all of it with you. So moving forward, the past. The past in Android is very simple, I would say. The past began with Java and XML. So if I see here the people who have attended, many of them I know you guys are web developers, and almost everyone is familiar with HTML coming from their school life. That someone or the other has learned about HTML. So the past in Android UI development part comes from XML. XML is extensive markup language, and it is basically not your programming language that you use in Kotlin. Like you have been taught Compose this few days, and it was all in Kotlin. But XML is not your basic programming language where you can write for loops and you can do all the logic coding. XML is more of a markup language. Markup language is very much similar to English, where there are use of tags. Tags are something which I will explain in a bit. And using tags, using the basic English structure, you explain the computer that see, I need this color, so color should be white. I need this font should be Arial. In a similar way, markup language is something very close to English, and it is used mainly in structuring UI patterns such as HTML and XML. Also, there are other formats of UI designs, but the most commonly used ones and the most that became famous in the past was XML, and it is still being used. So it can be drawn parallels with everyone's favorite HTML. A well written structure can be made with your code, and using all your tags, using all your different types of annotations, like it can be your margins, padding, color, font, etc., etc. You can annotate it and mention it to the computer that, hey, I need this color, hey, I need this much of margin, hey, I need this button, blah blah blah. Whereas Compose is something more of a function based. No predefined tags. Okay. The one very interesting difference between HTML and XML is that HTML has a set of predefined tags such as break, div, span. You guys have heard about it, and it is consistent throughout web development. Whereas in Android, XML doesn't have any set of predefined tags. There are a hell lot of tags. There can be customized tags being made, and you can use those tags to like. So color can be a tag. Color is to use to set a color. You can make a new tag which can be used to set, for example, you can make a new tag which can be used to set a shadow of any UI element. So there are no set of predefined tags in XML which distinguishes it more from HTML. That's the difference that comes up. And last but a very important point in XML, that it focuses more on good writing practices. Like as we as developers, we don't focus much on writing practices. We don't focus on indentation. We don't focus on writing codes properly in a structured way such that the other person understands it. But XML is such a language that it focuses a lot on writing practices. Otherwise, your code does not get compiled. Even in HTML, if you check it properly, like when you have written an opening bracket and after that you haven't written the tag name, an error will come up. So such types of things don't come up in Java or Kotlin, any type of programming language, because the programming language understands when to stop the compilation. Whereas in markup languages, a good writing practices are focused. It should be case sensitive. Case sensitive something is that in HTML you have seen that body in capital BODY and body in small BODY means the same. Whereas in XML it is case sensitive. It means if you mention color COLOR in small versus color in capital, it means different. So it should be case sensitive. Is it preserves white space. Preserving a white space means that you just cannot put up spaces anywhere, like we do in writing. You guys have done data structures at some point. You might have studied in your first year. And in C language, we just put a white spaces anywhere we want to write the code in a proper way, and then the code runs. Whereas in XML, there need to be a proper structure involving the white spaces and as well, such that your code gets compiled. So this is the past that can be said in Android development, in the UI development, and XML is widely used and still being used in that. Now moving forward, the present. The present is Compose. Compose basically uses Kotlin, which is another programming language, and Compose is something which can be called as a framework, not exactly, but it can be called as a framework built on Kotlin. So, what benefits it bring is that first of all, it's a programming language. Kotlin is a programming language, means if you know Java, if you know C, if you know C++, you can easily handle out Kotlin. So that brings up Compose is built on Kotlin. So you are building your UI elements directly with a programming language. There's no need to learn some other markup language to build of that sort. Cool. Now, anybody here who has experience in Flutter might have, if you have even explored Flutter, you might have used Dart, and you must have made UI elements in Flutter as well, which uses Dart. So Compose has a very similar structure where there are UI elements in Flutter, and it follows the same structure where we use the programming language Dart in Flutter to make UI elements. In the similar way, we use the Kotlin programming language in Android to make elements using Compose. And here, the very distinguishable property is functions instead of tags. In Android, in XML, we always use tags to make anything. In XML, basically, for example, if we have a button, there will be a button tag. If we have a text view, these are some things, if I say, you might get an idea of it. So text view is something which has the text. So if we have a text view, we'll have a tag of text view. If you have a button, we have a tag of that. But in functions, we don't have tags. But in Compose, we don't have tags. Instead, we have functions of it. So basically, you have composable functions. Composable functions are more, it can be said as functions which are broken into small parts. I will discuss more on that later. But functions define everything. There can be functions to set the margins. There are functions to set a button, a size of a button. There are functions to say, set the size of a column. The size of the column can be of the length of the full mobile screen. There are functions to set the width of a row. The row width can be a full length of the mobile device that you're using. So for each and everything we use functions in Compose, whereas the same part we used to use tags in Kotlin, tags for UI development in XML. And the last and most important part is that why Compose came is because of good coding practices. When we use XML, we are writing something on a different file, that is the UI part, and we are how the UI works. Like when you are clicking a button, you will move to the next page. When you are scrolling a sheet, you will go down. When you are scrolling a sheet up, you will go up. All the UI part, it works in a different Java code or in a different Kotlin code. So for bringing and merging these two things, we the Compose was introduced by the Google team, and it focuses on more good coding practices. Like the UI code is broken down into smaller parts, because if you have even tried out XML, there is a I will detail more on it. There are things called layouts, and in XML, everything is more encapsulated under layouts. We have a layout inside one layout. There can be another layout inside another layout. There can be two buttons. There can be multiple more branching. Whereas in composable functions, we divide the code into smaller subsections, and we make it into smaller parts and then merge it into one. Instead of uh, if you have a basic idea of data structures, I can relate this with recursion and DP, where dynamic programming, we take smaller parts and go ahead, and whereas in that is done in Compose, whereas in XML we are using recursion where we are going one layer into the other, into the other, into the other, and we are writing the code. And one very important point is minimizing coupling and maximizing cohesion. I won't say what this is. I've got a dedicated slide for it to explain you this thing, because this is a very good software development practice that you should understand. So for that, I've got a separate code. So that's what Compose it is as of now. And moving forward, the future. Who knows the future anyway? We have no idea. If we draw any parallels with Android, the past was Java. Currently, Kotlin is going on. The future was said to be Flutter, but Flutter found its own niche in different segments. So we don't have a future yet in Android development, the basic logic part. So I don't see any future currently in UI also. So let's see what happens ahead. Moving forward. Okay, so let us know material UI first. I wanted you guys to come across this because building UI is okay. You can see a lot of tutorials, you can build UIs, but the UI should be something that should be eye catchy and should be useful. And that is something that Google developed a few years ago. and it was supported from Google Lollipop. If someone remembers the Google Lollipop version, it was supported from that version. So it is a design system created by Google to build consistent and high quality digital experiences across platforms like Android, web, etc. So Material, even you guys have known that from, if you guys have seen the Google I/O last year, from Google 12, Google has introduced Material U. So Material UI can be said as the first version of Material U, and it is currently the complete industry, except for a few companies which have their own designs like Thread, which is neomorphism and glassmorphism, and some few companies build their own designs on top of Material U. But Material U is the baseline which you need to learn before moving on to UI development in Android. So it is inspired by the physical world and its textures, including how they reflect light and cast shadows. Material U takes a lot of benefit of colors, shadows, sizes, and gives you a real world idea of, even when you press the button, if you should have a feeling that you're pressing the button and the press of the button is going inside. So that's what Material U has achieved and Google has developed. And there's something that I've added here, and I wanted to open this website to show you guys first. Yeah. So, is this website visible?
Yes, yes, it is.
Yeah. Okay. So, this is the material design website. It's very simple, material.io. I would ask everyone who's joined this event, just open up your phones and check this website right now only. It's super, super awesome, and it's super, super useful for you to become a developer going ahead. Because if you are going into front end development, if you are sticking to web, if you are sticking to Android, and not going into backend, then this will be super, super, super useful for you. Each and every person in the industry uses this. So if you go to the design pattern, you get all the design and how they have introduced all the studies, and how they have incorporated various designs throughout the industry to implement a very generalized version across apps and web. If you move to components will show you the components is like a gold for a UI design, because it shows you all the components that's available under material design and that can be implemented. And this looks like an exhaustive list, but using this you can do non-exhaustive UI screens, that's for sure. There are multiple components. I won't go into depth. I have a different slide for this, but these components are so much essential to learn how to make UI development in a good standard way. Now, if you go to the develop screen, you will get a lot of their resources, their tutorials. It's separated into, like, for Flutter you have separately, you have for Swift is basically for iOS development, you have for web. So it's separated and you have all the components together. And Android is there. Material U was initially developed for Android. Like, for example, if you have heard of Firebase, it was initially developed for Android. So it is all the designs are Android first. So you have an not uh, I was lazy writing this out, so I just gotten a picture from the internet. So basically, this is an exhaustive list, but Android UI components are such that you can make multiple custom UI components of your own from this UI components. So like it gets into a non-exhaustive list. And if you go into the industry, if you check out any app, or even in any open source app, you will have multiple different UI components made out of this. So let me give you a small very tiny briefs of this. So text view is the most basic, the most basic part that can be of any UI element. The first app that I built in my life, it was in 2018 December, that just had a text view and a button, and there were some functionalities involved. So even if you're starting, you're very new to Android, just use a text view, use a button, and that's it. And think something out of this and make an app. That's enough for you to start with Android development. Then comes edit text. The second app that everyone builds in Android that generally I've seen is calculator. And calculator is something for which you need some input from the user. So for that you need edit text. Edit text will give you some custom input from the user, and it can be a number, it can be a string, it can be password, anything. And if you are making any app using edit text, I would suggest try to imitate a login screen or a login form of any app that you like. It can be Zomato, it can be Paytm, it can be Cred or anything. And make a login screen and use edit text, buttons, and text views. This three would be enough for you to make a login screen. Then moving forward to button. Button is pretty self-explanatory. Does the job of a button. Image button. Image button is something which has an image on top of it, and it does the job of a button. Basically, pressing on it opens, does some ABC work. But honestly speaking, image button is not something which is widely used. It is almost not used because image button has some restrictions in how the image is shown in the UI. So instead of that, what we generally use, that we just use an image view. An image view contains your image, and we use that image view. We write some logic. I won't go into the code now, otherwise it will confuse you. We write some logic, clicking on the image, it will do some function. So image button is something which is not very extensively used. Moving on, there's toggle button. Toggle button is something like when you have any toggle state, like you any yes no type of thing, then use a toggle button. Now radio button. Radio button is something like it's hollow from the inside, and once you click it, it's pressed. So like whenever you are choosing any option, then radio button is used. One at like radio button and checkbox, they have a pretty similar functionality. Checkbox is something that we are checking out something in a list, and radio button is also something you are selecting something. So when you're making a to-do list kind of app, then you can use a checkbox. Otherwise, when you have a selection type of scenario, then you can use a radio button. Radio group is something which like brings in all the radio buttons at one place. Like it's an extensible form of a radio button. Then moving on to rating bar. Rating bar is pretty similar, pretty simple. You might have seen your apps in Google Play Store. They pop up for rating, like give me this much of ratings and all of that sort. So rating bar is used there. Checkbox, as I've already said, is for checking list items. Progress bar. Progress bar is very crucial. In any app, whenever you build an app, there is the front end and there is the back end. The front end is the part that interacts with the user. The back end is the part that does all the data work, all your data crunching. You need some data from the app. You take some data from the app. All of that is done from the back end. And the gap between these two, there are some milliseconds of gap, or even it can lead to some seconds of gaps. Even there are if you have heard the word APIs are used to connect front ends and back ends. So there is some kind of delay in that interaction, and that delay is solved by progress bars. The default progress bar in Android is a very simple horizontal progress bar, which like a green light goes in and it completes. But you can make multiple random progress bars, like customized progress bars that you want to. And progress bar is something which you should have in your app to make a proper experience. Now moving ahead, spinner. So spinner is a very interesting utility. Spinner is not exactly like a progress bar, but you might have seen that loader in the center of the screen. So there can be use cases when in the UI front only something is lagging for you, or you need some data from the user. So you can show that spinner where in the center it's spinning, and then meanwhile you fetch the data from the user, and then the spinner goes off. So spinner is something which is more of used in UI interactions, whereas progress bar is something progress bars are more of used in when we are interacting front end to back end. Then there is time picker. Okay, time picker is something very interesting. Time picker basically shows you a basically a hour, minute, and AM, PM timer format. Time picker can be of different styles. It can be digital, it can be analog, and that sorts. But throughout Android, it is used as digital only. And whenever you need some input in time from the user, never use edit text that you are asking the user to input the time, because whenever a user inputs a time, it can be wrong. Like if there is a time for 9:35, I can write it as 0935, or I can write it as 2135, or I can write it as 0935 AM or PM. So there can be a lot of discrepancies over there. So use a time picker where the user can automatically choose, user can understand and then choose what time he needs to. Date picker is also something similar. Date picker helps the user to choose a date. It has various formats, like you can show the year altogether, you can show week wise, you can show month wise, you can show date wise, day wise also. And generally the month wise system is followed, and always use a date picker also when choosing dates. Otherwise people type 020 020520 or 02/05/20, so it can create discrepancies. Next is seek bar. Seek bar is a very cool thing to use whenever you are whenever you are using any music player. You have obviously seen that seek bar which goes ahead, and you can control it to move ahead, and you can use it to set the instruction that's going on in a particular time. So seekbar has the basic use of listening to the user input and setting the instruction and giving that input to the UI. That my user has set that music timing to 1:35 or 2, something of that sort. So see, if you are developing a music app, which I obviously prefer everyone to do, I myself did when I was just learning Android, because developing a music app helps you to learn how to use the media player libraries, helps you to learn how to use seek bars and various other UI elements, and it helps you to learn how to fetch data music files are .mp3 files or .wav files in your basically in your phone. So it helps you to fetch data from your phone and then play it on your app. And there is if you move forward, there is an advanced functionality of background playing your song. So if you are learning Android, and if you have a learning experience of 2-3 months, go ahead and make a music player. Okay. Going forward, there is an alert dialog. Alert dialog is very simple. If something has gone wrong, it pops up in front of the screen that it shows you an alert. Then you can set a state like okay, yes, no, anything that you want to. And switch is something which is very similar to toggle button. So switch also has that yes and no functionality, and you can set a switch of like you want to switch on any element, or you want to switch on any function based on your UI. So switch also has a very similar functionality to toggle button. So these are all the Android UI components that can be implemented in XML as well as in Compose. I didn't go into layouts because layouts is something which is more XML focused. But since the session is on Compose, so I just mentioned all the components, because any UI that you build, you need these components going ahead. Okay. Now, moving forward, what is XML? Because you guys need to know why Google dropped XML and then move forward to Compose. So, on a more detailed way, XML has two objects using which all its visual components can be constructed. Some time ago, we just mentioned all this Android UI components. So that comes under view. View is an object. Using view object, all this button, your text view button, image button, spinner, checkbox, everything can be implemented. Whereas a new term that you see here is view group. Now, what does view group sound like? Group is something that it encapsulates some views. It sounds similar something to that sort, right? So view group is something which are called layouts. Layouts in XML files. Layouts basically are some, again, those are some tags. There are multiple layouts like constraint layout, relative layout, linear layout, grid layout, blah blah blah. A lot of layout are there. So layouts come under those view groups, and using view groups, you can like encapsulate. You can cover up all your views into the UI. Now I think so. Some people might get a little confused. If you have any questions, please drop in the Q&A. just as we go over the slides, I will check on it and we'll have a discussion on it. Okay. So speaking of Android, there are some specific XML files with specific purposes, and slowly you might be understanding why XML is dropped. Because first of all, if you see, there are 7 XML files that generally is present in every Android project, and there are even more, but these are the basic 7 XML files that they are present. One is layout files. Layout files will have all the UI layouts that you have made. Manifest files will have mentioned all the UI layouts that you have made. Like I have made a login screen, I have made a home screen, and so on and so forth. So manifest layout will have mentioned all of that. String files. String files, like for example, today all the apps in the industry are becoming bilingual, specifically the Indian apps. And even if you go abroad, if an app is from France, they have a support for English native as well as French. So in Indian apps, they are becoming bilingual. At least English and Hindi support are there. So when you build the app, everything you have written is in English, and the UI elements are also configured in English. But in string files, you can write all the you can translate your English text into other languages as well and mention in the string files, and that can be used when the user changes his language, and the app can automatically fetch that language from those string files and show the user that in Hindi or any other vernacular language. Now moving on to styles. Style files are something which are basically themes of, like, basically you want to make a customized style where, like, you want to make a text, right? The text size should be 24, the text color should be blue, and the text style should be Comic Sans. And you define that in a style. The style should be comic. You can name a new style, any style name you can give it. They are custom files, so you can name a style like Comic Sans blue, and that style will consistently, wherever you use that style will consistently have a size of 24, a color of blue, and a font of Comic Sans. So for that purpose, style files are used. Color files. Color files are something initially when I was learning Android, I thought it to be very useless, because even now if you open a new Android project and you go to color files, you will see that there are only three colors: primary dark, primary dark, and primary accent. These three are there. But now that I extensively use Android, and when I got to know about Material UI, I understood why color files are important. Color files are basically, Material UI has a set of hundreds of colors. I don't even know the count. So you just copy all the set of colors and put it under your color files. There is just one color file, and from that onwards, any material color that Material UI supports, and Material UI supports almost every color out there, every color that is compatible in UI development. So you can directly use that color, because otherwise the issue that you will face is that colors are in UI development or in UI UX, colors are depicted using hash codes, slash blah 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 blah, something is there. So no individual can ever remember any hash code, uh, except for black, which is FFFFF, and white is 000 or something. It was it. So you always need color files which have those color names mentioned, and along with that the hash codes are mentioned, so that whenever you are using any color in your UI, then you can directly fetch that color name and write it, instead of remembering the hash code or googling the hash code, like, hey, what will be the hash code for lavender, or hey, what will be the hash code for maroon. So that type of effort won't be required. Next is drawable files. Okay, so drawable is very interesting thing. You see this a spaceship type of thing in my presentation, right? So this is something that can be easily made in drawable. Drawable is something where you can make your images, and you can there are if someone is in UI UX, you are very aware. You must be very aware of vectors. So vectors are something which can be exported into drawable XML, drawable.xml. The file names are said in that sort, and then you can directly use those image elements into your app. The in app image elements can be used in two ways, two or three ways. One is you can define a vector, and the other one is you can use a drawable file, and the third one is you can use it as png, .png files, basically directly copy pasting. Drawable files help you, like, as earlier I mentioned about image button. So I want a button which is like the modern buttons you have seen. It is very curved out at the edges, and it has a lot of punchy colors in it. Even you can make colors like the first part is yellow, the second part is blue. So something of that sort can be defined in drawable. I can make a drawable file. The drawable file, I can name it as button background, and in the drawable file I can mention that the corner should be rounded, the left and the right corner should be rounded, the first color should be purple, and the second color should be blue, something of that. and then I can use that drawable file in my buttons, and then my buttons will look something of that sort. So drawable files are super, super, super useful, and throughout Android, you will extensively use drawable files. And I know people, I myself, and I know people who feel very lazy making new layouts in drawable, but whenever you make customized UI layouts in drawable and use it, it's much more scalable. And what is scalability? I will come to it at the end, because that is something if you understand now, it will be very useful for you going ahead. It is much more scalable. It is much more easier to use in your development. And last is dimension files. Dimension files is pretty simple. Dimension files basically help you understand how the dimensions are. For example, in Android, there are two, three types of dimensions. One is px. Px is pixels. One is dp, and the third one is sp. SP is generally used for your text sizes. DP is generally used for your images or any kind of margins and padding. And pixels is here and there used out whenever you design any UI in Android, Adobe XD or Figma, and whenever you import that UI directly into XML, you might have seen that the margins are mentioned in pixels. So these are the three ways, and those dimensions can be directly mentioned into those files and then used throughout the app. You can directly not mention in dimension files also, but it is a good, at the end of the day, it is a good coding practice to mention in these files. So this was a very superlative introduction to XML, and I wanted you guys to know about XML, because so that I can explain you why Compose. Because if you don't know about XML, you will think that, oh, Compose is a new thing Google introduced, we need to learn it, blah blah. No, there is some reason why you need to learn Compose, or there is some reason why XML is slowly being deprecated. Moving ahead, why did it lack? UI and logic in separate files. The first main issue. XML UI in one screen. Your what the button will do, what the text view will do, what the text will do, everything in another screen, everything in another file, which is either written in Kotlin or Java. So XML has that issue where the UI and the logic both are in separate files, and at the end of the day, if you use your common sense, it is creating much more extra XML files. Number two, boilerplate code written to integrate with Kotlin lines. If you guys have heard of recycler view, that is something a little advanced in Android. But recycler view is something which is made to implement a list. A list is something which is a WhatsApp chat. Or WhatsApp chat is a list because you can see a list of people when you scroll up and down. Your Facebook feed is also a list. So whenever we implement something called a recycler view, we have to write a hell lot of code, a boilerplate code to integrate those that UI of recycler view with my Kotlin files. My Kotlin files will do the logic part, where he or she will interact with the backend, and then will integrate with the UI to send him data. Like my Kotlin file will get my message from my friend in the backend, and then send it to the UI, where the UI will show you the message. So, but for implementation of any type of complex logic in UI, a lot of boilerplate code is written. Boilerplate code is, in simple words, a lot of extra code is written in XML. So this was another issue that it had. It was more detailed and informative in nature. Now this can be a little dicey or a little metaphoric, that you can say that it is more detailed and informative, but it is how it is. XML is like Java. If you know even a little bit about Java, Java is a very long language. We call it as a very long language because you need to write long lines of code. Whereas you might have seen your friends of C++ and Python, they are writing very shorter codes. So in a similar way, XML is very, very detailed, whereas Compose are very shorter codes. So this can be called as an issue that we are facing currently, as developers are becoming more faster in development. So this is one issue that it faces, and extra XML files increasing final APK size. And as you have seen, there are 7 XML files at least that you will get in every basic app development that you are doing. So there are so much more extra files that are generated. So this, at the end of the day, if you just use your common sense, you will understand that the APK size will increase. APK is your app size that you download from the Play Store. So that's why we wanted that we need a new solution. We means the Google people thought, and after getting feedback from the developers, that maybe we should build something that now we have Kotlin going ahead. So maybe we should build something of that sort which supports Kotlin. And Google had already before even Compose came, Flutter was already in production and it was ready to use. So Google folks already had the benefit that they had an understanding of how users are using widgets in Flutter. So maybe something composable functions we can create in Android. Okay, so what's with Compose? Jetpack Compose has composable functions using which all the visual components can be constructed. I gave you a list of visual components earlier, and what we use in XML is tags to make those visual components. In a similar way, we use composable functions, and don't get like weird out with this composable term, because composable is something that is just used because we can break it down into smaller parts, all, and we can use functions to use it through. But going and making it very simple, just replace your tags with functions, and writing it in Kotlin is what helping us to make those visual components. And speaking of Jetpack Compose, there some generally used functions that I will go into, and extra you have all those components to be used. You might have you have already seen if you attend those previous sessions in that, and if you haven't, please take the session recordings from your GDSC lead. So there is preview function, there is row function, there is column function, vertical scroll, lazy list, etc. And some time ago I was mentioning about recycler view. A lazy list is something very similar to recycler view, where we implement a list, and it is lazily called. I don't want to go into the depth of what lazy calling is. It's not the time for a basic introduction to explain this, but it is similar to recycler view, where a list is implemented. Going backwards, vertical scroll is something whenever you are scrolling something in the screen, the elements in your UI has like for smaller phones, take it for example 5-inch phones, older and Samsung or Micromax phones. When the UI elements are a lot in number, you need to implement scroll. Otherwise any user won't be able to see what's there in the complete UI. So vertical scroll is something like that. Column function is something where all the UI elements, for example, there are two text views. The text views will be aligned in like a column fashion, 1, 2, 3 in a column state. So that's column function. Sorry. Then there's row function. Row function is something where all the UI elements will be in a row state, like element 1, element 2, element 3, element 4, in that sort. And going back to preview function is something which helps you to see your code, to preview your code even before you launch it into an app. So basically, you can see your code in your IDE. IDE is basically your Android Studio. Whenever you are coding, you are writing some code, blah blah blah, you have written, and then you can see your changes in your IDE. How is it looking? Then you can run it on your app. And a very like not a tip only. It's a truth is that what that looks in the IDE is not a bit similar that looks in your app. So in your Android phone. So always, whenever you are coding something and you are making a UI, once you're done with the UI, keep once not only once you're done, after every iteration, after every change in your UI, always install that app on your phone and check how the changes are looking on your phone, because your ID and your phone shows you very different results. And that I've seen with like 3 years of doing Android, and that still happens. That is something that hasn't gone yet. So I personally also don't encourage people to use emulator because of that, because emulators give you some different idea, and whenever things go into production, whenever actual people are using it, people see some other UI, which can be a blunder. Okay, and before moving to the other slide, just I've added that etc. here, because there are multiple other functions. Like Jetpack Compose is totally functions. So there are a hell lot of functions out there to implement anything that you want to. So I just added etc. there. So like there is a button function. There is text view. Everything that you can implement in XML can be implemented here. So that works using functions. We are implementing what we used to do earlier. But the main thing what we are doing is that we are not maintaining a separating file. What we are doing is inside our own Kotlin file, code file that we are using, we are writing our UI logic as well. So that's it. If someone has any issue, like questions up to here also with Compose, please mention it in the Q&A. Okay. So what does it solve? As I have already said some time ago, it maintains a single code base in Kotlin. So you don't need any other XML files. You just can write your main, like there can be one single screen, main screen.kt. Main screen will have your UI. Main screen will have your logic, like hi, my name is Anirudh, your DSC lead, something of that sort. He can mention if Anirudh is making an app, he can mention that in his main screen by just writing the code there, as well as making the UI in that Kotlin file only. Second, UI code is broken into smaller functions. As I've given a previous analogy to DP and recursion, here things are broken into smaller parts. The composable are broken into smaller segments, and then it is implemented rather than like nesting things into one another and then showing it to the user. So this breaking up into smaller parts helps you write code more efficiently, brings in new UI elements like animations. So animations is something if you guys know your previous GDSC lead Jyotimal, he is a person who is very good in animations, and I personally learned animations from him as well. So animations is something which is pretty tough to implement in XML. XML animations, like in XML, actually you even can implement animations of that sort. There are not proper tags present in XML to implement animations. At the end of the day, we need to move to Kotlin. We need to write some Kotlin functions to implement animations in your app. It can be your button rotating, it can be your text view like coming out of the screen, coming forward, anything it can be. And animations is something, all of that lines of code we used to write in the Kotlin files. So what does Compose is doing? It simply it doesn't have an XML sheet only. So obviously you have all of the animations into a single code line. So it helps the UI elements bringing in more detailed animations, more beautiful animations, and make you, at the end of the day, as the industry is going forward, you are seeing the apps are becoming more and more prettier, and that's building more app engagement. And app engagement is something which every app requires, which every user requires, because if you are not in an app for more than a minute or so, then that app is not very interesting. So um, uh, what uh, what animations does is that makes the app look more eye catchy, more beautiful to the user. And last is optimized code build and APK size. APK size is something, as I've already mentioned, you don't have XML files, so APK size will obviously reduce. And optimized code build is something which is again a controversy or like dicey thing that you can say, because there is still research going on that XML files run faster or Compose files run faster. I can share some Medium links on that as well. I've read most theories on that as well. It is being observed that whenever an app is loading for the first time, Compose a UI built in Compose takes more time. Whereas whenever an app is loading for the first time, XML files take less time. But whenever you're multiple times opening an app, whenever your app is in background, Compose opens faster, whereas XML opens slower. So that is a very trade-off thing that you want to know, but it is still dicey. So these are the things that it solves. Basically, Compose solves. Okay, so I had mentioned about coupling and cohesion, and this is the main coding principle in Compose, not reducing XML files, but to introduce coupling and cohesion in Android. So, what is coupling and cohesion? I will take a bit of time here in this slide because it is a little bit on the advanced side. It is more on like writing proper code and proper software developmental practices. But I want you guys to know, because if I had that exposure during my time, I would have known much more. So I want you guys to know more about this. So coupling is something is that do you guys see two boxes here? In these two boxes, there are in the first box there are three elements, and in the lower box also there are three elements, and these elements are connected to each other. So this is called coupling, where there can be two files, and some code in these two files are connected to each other. Coupling is the dependency among units in different modules and reflects the ways in which one module influences parts of other modules. So let me move to Android. How coupling works in Android. So for example, I have a Kotlin file. The Kotlin file has all the logic that when you press a button, you print my name. When you in the text view should have the text as a password. So these are the two logics mentioned in the Kotlin file. And in my XML file, I have written I mentioned a button, and I'm writing coupling. I'm mentioning coupling here with Kotlin and XML because that's what was the issue earlier. So in my XML file, I have here a button mentioned and a text view mentioned, and the text view takes a password as input. Input type is password. So now I have that code in Kotlin file coupled with my XML, which has a button here, and I have that text view code in my Kotlin file coupled with my XML in text view. So that is called coupling. And what happens with coupling is that whenever you have made any change in your code, for example, you have made you have in Android, whenever you are writing in XML, you mention your, there can be multiple buttons in a screen, right? So I mean, you mention your every button with an ID. So it can be ID1, ID2, ID3. So for example, let this be let this button be ID1 and the text view be ID2. So for example, you have changed the name of this ID1, ID12, you have changed it to ID button. So what will happen is that when you run the code will break, because the Kotlin file, it has your button has ID1. It knows that I need to I need to catch the UI ID1 where the button is implemented. Whereas now the name of the button has changed to ID button. So the code will not understand of anything that what is going on. So for that, coupling is where it breaks. That's why in any software development practices, in anything that you code, even if you go to backend also, we want the dependencies less in files of different modules. If files are of same module, for example, if files are of for example, if there is a module of Kotlin files and files are of Kotlin files that are dependent on one another, then that's a different scenario. Their coupling doesn't works in a stronger way. But when files, there is a .kt file and there is a .xml file, then coupling works in a very stronger way, and it is a very restricting way for a developer to go ahead. So in software development, we always want coupling to be less in files of different modules, in files of different extensions, in files of different functionalities, different any different use case where files are used, we want that coupling should be less. Now moving to cohesion. Cohesion is something that is composed, or cohesion is something that is widgets in Flutter. Cohesion is instead the relationship between the units within a module and indicates how well grouped the units in the module are. Okay, so now let me take this box as a Kotlin file only, and now I am in Compose. So now I have a Compose file here, and I have my code written here as well as I have my UI written here. Because in Compose we are writing the UI in the code itself. This has been clearly established in this last few 3-4 sessions. So whenever a change is happening, it is inside that file only. So the chances of breaking is much more less, because whenever you are compiling the code, instead of runtime, whenever you are even compiling the code, you are getting that, oh yes, the file name has been changed. I need to for the button name. We are going to the previous reference. The button name has been changed, so I need to correct that also. So in compilation only, we don't face issues in runtime that we are facing in coupling. To make things a little more easier, runtime is something like whenever you run your app and your app crashes, that is called a runtime issue. And whenever you are building your app and an error comes up, that is called a compile time issue. So in compile time, you are already getting that yeah, this is an issue that's coming up, and maybe I should fix it. Uh, Obviously, it will fix it, and that helps you in cohesion, because cohesion is something where inside one module you are getting all those things fixed together, and also all those things are attached to one another, rather than going to a different file altogether, rather than reaching out a different module altogether. Ki, hey, this is my file I want. Can you let me know how to function it? Rather than that, you are in your own module. You can just search it up. That yeah, I need to check this file, and I need to check out where the error is coming up. And then this is something how cohesion is achieved. So this is one line that I've copied from Medium, and this is a very golden line. Is that when writing maintainable software, our goal is to minimize coupling and maximize cohesion. So whenever we are writing any type of software that goes ahead, and if we are implementing a very large app, for example the YouTube app, if we are implementing it in previously it was obviously implemented in XML, but now migration has started to Compose. So if we go on writing very huge apps in XML, there will be a lot of coupling involved. Hundreds and thousands of files will be attached to hundreds and thousands of UI files, .xml files, and that will not be helpful for the developer to implement new features. Developer will not be able to manage error handling properly. Developer will not able to implement multiple new features, because he obviously have to look up every other file and check to which Kotlin file it is attached, and then change its code. So that's how coupling and cohesion works, and why do we need to minimize coupling and maximize cohesion. Now I'm very sure there can be still like questions out there, so please put up on the Q&A if there are any questions out there. Now there is one thing that I haven't mentioned here, I forgot to mention, that is scalability. Scalability is something that is hindering Compose and why Compose is still not out there in the market, like totally wildly out there in the market. You will still get XML. In XML, I agree that apart from that, animations is still a barrier in XML. But apart from that animation, you can do any UI, your UX. There is a UI UX designer in every team. So your UI UX designer can give you any UI, anything that he or she can think of, and whatever UI that you get, you can surely implement it in XML, and that will not break. That I can guarantee you right and here for sure that it will not break. The UI will be clearly visible to the user. Whereas in Compose, you have that constraint that you 100% cannot implement each and every UI out there in the market. If you pick up any app out there in the market, and if any complex app, for example, pick up the Cred app, it has implemented neomorphism. But if you try to implement neomorphism in Compose, it won't be as easy for you as you will get to implement it in XML, because there are XML libraries present for neomorphism. So that's where scalability is hindering Compose to grow, because Compose is something very new. Compose was introduced in July 2019, and it's been just in 2022, as I've heard, the stable version of Compose came out. So before that, all the beta versions were going on. So it needs some more time, but it's good to learn in the beginning. Scalability is what is hindering Compose, but coupling and cohesion is what is helping Compose to grow ahead. So there is a trade-off that exists in the UI development. Now, just ending up the slides. Okay, so there are some gold resources that I've mentioned here. I have used the word gold because I have personally referred to them, and they have literally helped me a lot to learn. So one is Material. I have already shown. These two are UI in XML, and more designs of UI in XML to explore. Basically, this two will help you to learn XML designs in a greater length. The first one is on a more easier level, and the second one has multiple screens, and you can choose up whichever you want to do. The next one is Compose Basics in Android. Compose Basics is something which you need to learn initially. You need to learn all the functions out there, and how each and one more very important thing is state. State is something that doesn't exist in XML, but that exists in Compose. You guys might have learned a bit about it in the previous sessions. So please learn more on how states work, how the state of the data changes when even your app is when your phone is rotated from vertical to horizontal and whatnot, when the app is in background or else. So Compose Basics will help you, and if you want more detailed videos on Compose, this is the link, and I will share this PPT with you. I will ask Anirudh to share, and please refer to these resources to start with UI development in Android. And pro tip: if every fucking thing fails, official documentation is always the savior. So this has happened to me multiple of times. This has happened to every other Android developer out there, every other web developer out there who has done any kind of development. That if any type of document, if every type of video is failing, if you don't have an answer in Stack Overflow, if you don't have an answer from a senior, is the official documentation. It's very boring. I 100% agree with you. But if you read through the official documentation, you will have an answer to all your queries out there. And official documentation will give you the final solution to any question that you have. Okay. So I have talked a lot on why Compose and why XML was there, why Compose came in, what are the different resources out there, what are the different functions, how they are used, and whatnot. But the main question that comes up, because this is a concluding session, I want you guys to conclude with this and session and start doing Android development like today or tomorrow itself. So what do I use? I myself, honestly speaking, in my day-to-day life, I still use XML. I've started learning Compose a few months ago, and a few one or two screens I used in Compose. But as I mentioned, Compose recently became stable. So for production, it was breaking for multiple of users, because currently I'm working in an app which is used by 5 million users. So if it breaks for even like 1% of users, that are huge. That is a huge number of users, and then I get calls from a senior developers. So I'm still using Compose. We are slowly we are thinking to shift to. I'm still using XML. We are slowly thinking to shift to Compose. But even the market is also shifting to Compose. Many other big firms are doing that, but it will be a year or so when you will see that Google is Compose first. Like Google, if I say you about the history of how Android development came to use, when I started in 2018, Java was the preferred language for all your logic writing, and everyone used to use Java to write all that code. But in 2019, mid 2019, Google made Android Kotlin first, and it was in 2020 that I started using Kotlin. And now I personally myself don't suggest any person to use Java in Android, because that's well deprecated by now. Now Kotlin has all the resources that you want to, and it's very intermergeable. So even if you are using Kotlin files, we can use it with even if you have something very old library in Java, we can use it with Kotlin as well. So Kotlin is the way forward. Kotlin is the way forward. Means it is the future now. Means it is currently being used, and Java is no more in the Android scene now. Similar use case with Compose as well. Compose has this interoperability with XML, but Compose still has the stability issue with it. So it is good for your small projects going ahead. But I personally use XML. Now, what should you use? That is a much more important question, because the 20 odd people out here might. I'm sure you guys are serious with Android development. That's why you guys are here. So there are 3 pointers. If you guys have done any kind of Flutter development earlier, then go for Compose, because you guys might have had knowledge of widgets, states in widgets, and all of that. So go ahead for Compose, learn Compose, make some apps, and then learn some XML, because learning some XML will help you use complex UIs in a more how I explained you scalability. So learn some XML and use Compose to make beautiful animations and all of that sorts. If you are absolutely new to Android, absolutely you haven't touched Android, you have just installed Android Studio for all this Compose camp session, go ahead, learn a little bit of XML, explore what how XML works, and get an idea of buttons, text views. I've suggested some apps earlier, so make some apps. And this gold resources that I've suggested, getting started with, even if you just do this thing, getting started with UI and XML, that's enough. So do that. And if you like XML, you can go forward with it. But if you don't like XML, learn Compose, and you can directly jump on the more detailed videos on Compose, because if you have done XML, you have a pretty good idea of how UI resources work in Android. So then go ahead and learn Compose, and I'm pretty sure that is the way forward. That is the present for sure. And if you are already doing Compose, uh, first of all, just go ahead and Compose basics might be clear to you. And if it's not clear, check this out, and then go to the detailed videos on Compose in Android, and go ahead with Compose. And if you feel like sometime you want to learn XML, if you have that time, much of time, do it. But go ahead with Compose. There's no foundation on that. And whatever you guys do, whatever you guys are doing, the very first golden step is that today whole night you guys go and search out material.io, learn about all the components out there, learn about all the design principles, whatever you can learn from there, all the blogs and everything, read it out there. If you want to be a good front-end developer out there, go to material.io and learn from there. Now, a lot has been spoken. Let's go to the Q&A. Anirudh?
Yes, sir.
Yeah, so let us take some questions.
Right. Right, you guys can drop your questions in the Q&A sections, or just post in general if you want.
Yeah, anything that you want to ask to any type of question. I'm your senior at the end of the day.
Sure.
So everything works.
Right. Meanwhile, ask them. Can I ask something?
Yeah, sure. Go ahead.
Uh, uh, Compose Camp brings in state management, right, to Android.
Yeah,
Uh,
yeah.
how was this seen before that?
Sorry.
How did people maintain state-like structures before Compose came into the scene?
Yeah. Okay. So, Compose directly brings state management in Android, but earlier in XML, that coupling was hugely involved, where we used to store the state of all the data in saved state instance. That is something of where you get functions in on create or on create view in Android. That if you have used, you might have seen that. So using those bundles of data, we used to store the states, and whenever any type of state is changed, that bundle was used to restore. There is a function called restore save state, and such using such functions in Kotlin, we used to fetch that bundle of storage, and then we used to put in the data out there. So that is again involves a lot of coupling, because we are first fetching the data from the XML file uh, UI element, and then we are storing the data in some bundle, and then we are passing it out through. Whereas in Compose, you can directly mention the state of the data, it is a mutable state or whatnot, and then you can go ahead.
All right, thank you.
Yeah,
I think we have a question.
yeah. Okay, how is local storage used in Compose? So I'm not very clear with your question. With local storage, do you mean shared preferences, or using any kind of a local storage like SQLite or something of that sort? Deeptak, can you please clarify on this? Shared preferences. Okay. The best point of Compose. Bhaskar, I'm coming to your question next. So the best point with Compose is that of cohesion. That now with Compose we can directly, whenever we are writing the UI of the, for example, of text view, we can directly use whenever we are storing something in shared preferences, we can directly get the value from that shared preferences and input it into the UI, rather than fetching the value and then using data binding to store the data into the UI. So shared preferences has a very good integration with Compose, because directly in the code itself you can get the data local storage in your of your shared preferences, and then put it into the Compose layouts. I hope that answers your question, Dita. Yeah. Okay. What are the company's point of view of using Compose for their product? Okay. IN is Jyotima in this call? Okay. I and Jyotima, we are working at the same company right now, and we have made some like UI in Compose. And Jyotima, if someone doesn't know from the juniors, he's a previous DSC lead as well. So we have made some UIs in Compose as well. But the problem that we have seen is that for complex UIs, there is something called a heart rate monitor in our app as well. So if when Jyotima tried to implement that in Compose, there were some issues that were found out. It was not very stable. So that's what the issue that came forward, and then he had to move back to XML, where we had many custom widgets implemented using XML to implement that. So that's something we cannot build very extremely niche use cases with Compose as of now. I'm sure Google will add more support to it. So as of now, XML is the way forward that companies are using for those. But we are suggested by our Android lead to make simple UIs with Compose. So we are doing that, like tits and bits. Okay. I have one more question. So yeah, I can understand recycler view took if you, it took you a lot of time. From in my time, it took me 2-3 weeks even. So a recycler view is pretty hard. It has a UI. It has a UI integrated with two files, whereas general UI elements have one file integrated with it. In XML, XML has a recycler view, and it has two files. One, a dedicated file for recycler view, another a normal business logic file which has the recycler view mentioned in it. So I understand it can take a lot of time. So I would suggest you to check out lazy list and Compose. It's pretty similar, and the implementation is much simpler than recycler view. And after you get an idea of lazy list, then move back to recycler view and then try it out. So then you will get a very more broader idea of it. Cool. Anyone? Any more question? Open up like Dipta. I'm your senior, so be cool. Anything about college also works. Okay, Pratik, are you saying life cycles of components in XML and Compose? Okay, okay. For Compose, the life cycle works in a little different way than it used to work in XML. So in XML, after in a file in the on create view, the when the onCreate view is initiated, all the XML file is also loaded, and then the lifecycle starts. Whereas in Compose, the lifecycle is the UI is broken down into smaller codes. The lifecycle is more of that sort. Key whenever whichever part of the UI is visible to you, only that part is loaded onto the screen, and the lifecycle of that component starts. So handling methods in specific is not in a very detailed way mentioned in Google. But as I have read, like gone through some videos of Google developers, they have said that the lifecycle handling in Compose, there are not any external methods available as such, but they have handled the lifecycle in such a way that there is no loss of data. That's why the stateless and the state thing comes in Compose, because Compose, the loading of UI in Compose is much more different than the loading of UI in XML. UI XML loads the complete XML file, whereas Compose loads only those components that are visible to the user. I hope that's clear, Pratik. Anyone else? I guess I can stop sharing now. Anirudh, I think so. No more questions are there, and I took a lot of time. I was just thinking for a smaller session. Sorry, guys.
I mean, it
No,
was pretty detailed, so it was good, really good.
I
Uh,
yeah,
like,
the Compose should replace XML. So learn Compose. Yeah. I am myself learning Compose, so you should also.
no, the meet kind of reminded me of when I started to learn Android. That was like back in first year, and I gave up
Yeah,
around the time I tried to learn Recycle View. So, if I had
and
composed back then,
recycle.
I think it would be a lot easier for me.
Yeah, so recycler view is the biggest entry barrier to Compose. Yeah.
Hmm.
So anyway, just one last thing before like signing off. To everyone present here, all the juniors, the third years know this, but to the second years out there, whatever you are doing in development, that's great. Do Android, do web, whatever you want to, whatever you like. But at the end, do DSA. That's the biggest yeah, that, like tip I can give you, because I agree that the job that I'm doing is as an Android developer. I'm working as an Android developer here, but the first job that I got at Paytm, that was because of DSA only because of DSA. So do your development works. Whenever you have good projects in your resume, it will help you a lot in off campus. That's very sure. But do DSA, because at the end of the day, on campus placements are something which you guys will be aiming. So that will help you in your on campus placements as well. So all the best in your Android journey. Whoever have attended today's and still now in the meeting, guys, hit me up in LinkedIn. I am not much available in Facebook. So LinkedIn, you can search my name and you will get me up. If you have any doubts in Android, I'm always there. I am always there to help you out in anything. We can get on a live meet call and help you. So just let me know. Reach out to your GDSC seniors. The fourth years also. Everyone is there to help you out. GDSC is that community which helps you out. So please do that. And whoever has attended till now, I know you guys are serious about Android, so you guys are till now here. So please continue with it, and I hope to see you guys more in this field, more as Android developers out here. Because honestly speaking, this field is very niche. Very few people are there. So yeah, you have the demand. Honestly speaking. Yeah.
Once in,
Thanks,
thank you for
Anirudh.
being here. Thank you.
Thank you. Thanks, Pratik, Saurav, and everyone else present out there of the GDSC. Thank you so much. Bye bye. Bye, guys.
Bye bye.